So a stem and leaf plot, guys, is nice because it organizes your data numerically and it sort of like graphs it at the same time. It's not like an actual graph, but you can see things in the same way that you would in a bar graph. Well, more like a histogram, actually. So the stem is the first digit, and the leaf is the second digit, and you make a T chart. And then as you go through the numbers, okay, so I'm looking at these numbers. I have 12s, I have single digit numbers. I'm going up 50, 60. Looks like 66 is my highest number. So, 71. Okay, so my stems are going to be 0 for the single digit number. 1, 2, 3, 4, 5, 6, and 7. Probably should have written those smaller. Space it better. Should I just move this up a bit? Okay, so those are my stems, and then I have leaves. Okay, now what we can do, you can either go through and search them out numerically, or you can create 2 of these T-charts, the first one out of order and then the second one in order, which is the easiest way to do it. So I look, my first number I see is 20, so I put a 0 for 20, 20. And then I have 12, so I put a 2 for 12. 39.
What's 12 if they're twice?
38. We'll get to it. 18. 58. 49. 59. 66. 50. 23. 32. 43. 53. 67. 35, 29, 13, 42, 55, 37, 19, 38. Now see, 38 was already on there, but there's 2 38s, so you put a second 8. Okay, 22, 46, 71, 9, 65, 15, and 38. Okay. Now, 0, because there's no first digit, so it's 0. Okay. Now, let's say I was creating this and there were no 20s, but I had 0s and 10s and 30s and 40s and 50s. I still need to put the 2 there and leave them blank. Okay, so you always have to have those placeholders in case there's like missing 10s. And then this is not complete yet. We have to sort it numerically. So we have to put it in numerical order. So we make another T-chart, and again, you can go numerically at the same time as you're doing your initial stem and leaf and just go through and find them in numerical order, but it takes longer to go that route. This is actually faster because second, yeah. Because if I'm doing it numerically originally, I have to go through and find all the, I have to go through the list several times. Yeah, whereas this way I put them, and then it's very easy to see well, okay, there's only 9. But it's easy to see numerical order when I'm just dealing with 2, 8, 3, 9, and 5. So 2, 3, 5, 8, 9 for 12, 13, 15, 18, 19. Do you see what I mean? How easy that was as opposed to trying to find that through the whole list? And then 2s, I have 20. 22, 23, and 29. My 3s, I have a 2, a 5, a 7. I have 3 8s. Make sure you list them all. And a 9. My 4s, I have a 2, a 3, a 6, and a 9. 0, 3, 5, 8, 9, 5, 6, 7, and 1.
So,
Yeah, you have to put them in numerical order. It's required. I'm just saying doing it this way first, not in numerical order, is just going through the list and writing them all down, and then put them in numerical order. You have to write it twice. What I did first is I just went through the list and I put 0. Yeah, I just went through and did that. I have to rearrange them into numerical order. I rearranged this list to put them in correct order. 2, 5, 7, 8, 8, 8, 9. Right? They have to be in order. Okay? And it's faster to do it not in order and then sort it than to go through and try to go through the list and find all the numbers in order. This is a more efficient process. Once we have this complete in numerical order, you can see this is sort of similar to like a histogram, because I can see that I have more 30s than anything else. Quickly, I can see that. I can see that I have very little single digits or 70s. You know, I'm able to see things really fast. I can see my mode really quickly. That's the only number that has 3 of them in the same row. So 38 is my mode. And I can find my median. I count. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. So my median is going to be at the number between the 15s. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. My median is going to be between these two numbers. Well, they're both 38. So my median is 38. So it's really easy to look at this and find information. Not mean. I'm just like mode and finding the median on here. So, but like if you look at this, I can answer questions quickly. Let's say these were ages. You know, and I have 9 to 71. I can say how many people are over 40? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. You know, I'm able to answer questions very quickly. What was the most age range? Well, in the 30s. What was the least? Less than 10, older than 70. You know, you can answer questions really fast. So it's kind of a nice way to organize numbers. Any questions on how to make it so far? I don't have any single digit numbers. So I have to start with 1, and it looks like I'm going up to 60s. Yeah, so I've got to go 1 through 6. Okay, now if you don't have any 1-digit numbers, you don't have to put the 0 in there. But if you're missing digits in between, they have to be there. So you can start it wherever and you can end it wherever, but you can't have any missing numbers in between. Okay? So I have an 18, a 39. I'm just going down the row. 57, 48, 30, and then 10, 41, 53, 56, 41, 37, 49, 51, 33, 51, 36, 50, 57, 36, 38, 61, 52, 39, 19, and 60. Okay. Then I'm going to sort them. Oh, that's crooked. Oops, I don't need zeros, sorry. Okay, so 0, 8, 9, no 2s. 3, no, sorry, 0. Yeah.
So we can't just drop 2.
You can't. You have to, you can leave out numbers before your first digit, And you can leave out numbers like after the end, but you cannot leave out in between. Okay, because that tells us something, you know. So I had a 0, a 3, 2 6s, 7 and 8 and 2 9s, 2 1s, an 8 and a 9, 0, 1, 1, 2, 3, 6, 7, 7, and 0 and 1. Okay, and now we want to list 3 facts. Just from looking at this right now, I can tell you no plants are in the 20 centimeter range, like right off the bat. I can tell you that most plants here, we've got 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. Most plants are in the 30 or 50 centimeter ranges. Okay. And we have 1, 2, 3, 4, 5 modes, so I'm not going to list all of those. That's silly. But I can say that, not very many plants are in the 60 centimeter range. I have other things, so like only 2 plants are 60 centimeters or greater. Yeah, you could. I was just running out of space, and I didn't want to list the 5 modes. So, but see, it was really quick to look at this and come up with facts about the plants. That's the beauty of the stem and leaf. It's a fast way. That's what we're trying to do with all of this, all of the graphing that we're doing in this chapter is fast ways to interpret data. Just to be able to look at a graph or a way it's organized and be able to say immediately things about it without having to do a lot of extra work to get that information. Following stem and leaf plot represents the ages of 23 people waiting in line at Tim Hortons. No idea what that is. Okay, what is the mode and the median? No, what is it in this numbers? Yeah. The mode is the number that appears the most frequently. We have these 3 2s, right? So remember our mode then is 32. So most people in the line are 32. Okay, the median.
I have a question.
Yeah.
If you have a set of numbers that starts off with 4.
To find the median, we count up how many numbers we have. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 numbers, right? So we have, there's 23 numbers, and I want the middle. So if I divide that by 2, I get 11 and a half. So the middle number is the 12th number. Because I'll have 11 on this side, right? I'll have 11, and then 1, and then 11. And that gives me 23, right? Was that the 12th number? Oh, sure is. Okay, so the median is also 32. How many people are older than 32? $11 people. So, how many people aren't adults? Yeah, not adults. 18. 18 is legally an adult. 3 people are not adults. Nobody's a senior citizen because we're only going up to 57. 65 is considered senior citizen, yeah. But see, like we were able to answer these questions relatively simply. Yay. No, I didn't mean to. Ready? All right, bar graphs. you guys are very familiar, I'm sure, with bar graphs, but bar graphs represent data very visually, and bar graphs are one of the few graphs that can represent both qualitative and quantitative data. Okay, most graphs can only represent quantitative data. But with a bar graph, you have the bar height or length that represents frequency, so the number of times that something occurs. And the categories are represented by intervals of the same width. And those categories could be numerical categories, which is quantitative data, or they could be things like colors or flavors or pets or cars or whatever, being qualitative data. Okay. Typically, the categories go on the horizontal axis, the frequencies go on the vertical axis, and the bars go up and down. But they can be flipped to where the bars are going sideways. It's just less common. So I am constructing a bar graph to represent the depths of the Great Lakes so I can quickly see which ones are deeper. I have 29 spaces here. So there's 29 spots. But I need 1,333 feet worth of space. Okay, so if I divide that by 29, that gives me 45.9, which tells me that each box should be more than 45.9. So I'm going to make them 50 just to be easier. So that gives me my scale. So I take the largest range, divide it by how many spaces I have, and then come up with my scale from there. So 50, this one's 100, 150, 200, 250, 300, 50, 450, 500, 50, 600, 50. I didn't put it, it's right here. That's 50, 100. I'm going up by 50s, but I'm only writing every 100 because otherwise it's too crowded and I can't see. Does that make sense? Okay, so there's 600, 650, 700, 750, 800, 850, 900, 950, 1,000, 1,050, 1,100, 1,150, 1,200, 50, 1,300, 50. Okay, and then 1,400. Okay, Lake Superior. I have 5 lakes to go across. I'm going to make each bar 3 wide. You want to make your bars even. So if you color in one column to make your bar 1 column wide, then all your bars need to be 1 column wide. You don't make one column wide and one 4 columns wide. You know, they need to be even. Mostly just for aesthetics probably, but that's just the way things go. So I'm going to do 3. So this is Lake Superior. And then I'm going to move 2 places over because my bars are not going to touch. In a bar graph, your bars don't touch. Okay, so then that's Lake Michigan. And then 3 more for Lake Huron. 3 more then for Lake Ontario. And then Lake Erie. Which one did they forget? Oh, I thought somebody said. Okay, Lake Superior is 1,333 feet. Here's 1,350, so I'm going to be just below 1,350. Okay. And I am going to make Lake Superior red, because why not? And I'm going to color in my bar. Okay, and then Lake Michigan is 923, so here's 900, and then just above 900 for the 923. Probably should have gone a little less above, but. And Lake Michigan is, blue, like the actual lake is. And Lake Huron is 750, so I actually have an exact line for that. Lake Ontario, 802. What color should I use for Lake Erie? Purple, okay. 210. So here's 51, 52. That's too tall. And there's my bar graph of the depths of the Great Lakes. Sometimes we're not given the frequencies or the data, so we have to do a tally, and we count them ourselves. So Ford, Honda, Volkswagen, Mazda. So I have a Ford, 3 Mazdas, a Volkswagen, a Mazda, a Ford, a Mazda, a Ford, a Volkswagen. So Mazda, Ford, Volkswagen. Honda, Honda. Ford, Volkswagen, Ford. And then on the next row, Honda, Honda, Ford. Mazda, Mazda, Volkswagen. Honda, Mazda, Volkswagen. Volkswagen, Ford, Volkswagen. Oops, Volkswagen, Ford, Volkswagen. And then Honda, Mazda, Ford. Okay, so there's 8 Fords, 6 Hondas, 7 Volkswagens, and 9 Mazdas. Two, 4, 6, 8, 10. Okay. And then Ford is going to be 3. Bless you. Honda. VW and Mazda. So we have 8 Fords. Black? Purple and black, are we being gothic? Okay, 6 Hondas. 7 Volkswagens. And 9 Mazdas. Okay, and we can quickly tell from this that Mazda was the most popular car. Okay, ready? All right, we're going to answer what type of show is watched the most? Sitcoms. Quiz shows is watched the least. Okay, this one is going to take a little work. We need to figure out, that's about halfway between, so we'll say 15 there, and then 35 here, 5. What do you think, like 18? 20 and 45. Okay, when you add all those up, you get 138 students. Okay, so about 138 students participated in the survey. And right, the answer is no. We have no difference between male and female. We just know differences between shows. Any questions on interpreting the paragraph to interpret? What is the most popular part-time job? Not the favorite, just Yeah. What is the part-time job held by the least number of students? Tutoring. Okay, what jobs employed 10 or more students? So here's the 10 line right here. Okay, yeah, wait, you forgot one. Said 10 or more. Yeah, and lawn. Okay. Is it possible to create a table of values for this bar graph? Sure. We just say, okay, here we go, and we have the job, and then we have the number of students. Okay, so yes, it's possible, and it's right over there. And so if I have babysitting, we have 8, and then fast food, 14, and delivery, 12, and lawns are 10, and groceries are 13, and tutoring is 5. So yes, we can make a table looking at the bar graph very easily. Okay, what percentage of the students worked as a delivery person? Okay, well, we have 12 out of 12 students, but we need the total number of students. Say if we add all of these numbers up that we just came up with, we have 62 students. Okay, so we have 12 working delivery. We divide that by 62. That gives me 0.194. So 19.4% of students work in delivery.